Hello everyone and welcome back to my channel. Today we are going to talk about one important technique in prompt engineering, which is chain of thoughts using the in-context learning. And we will have another video talking about the prompt engineering with in-context learning. Okay, today we are going to use LLaMA-2-13B chat variant model, and we will see again how we can use it from NousResearch and from Meta LLaMA. Okay, so first of all, we need to understand what is in-context learning and what is chain of thoughts. Okay, for in-context learning, it happens when I ask the model to learn from the prompt window itself or from the prompt itself without the need to train the model parameters or tune the model parameters for a certain task. So how we can do that? We actually let the model to learn the task that we need from the examples in the prompt that we give it. And during that, we can give no example, and this is what we mean with zero-shot prompting, or we give it one only example with its answer. So this is one-shot prompting, or a few examples, and this is what we call it the few shots prompting. And from that, the model will start to imitate the way that you are answering the examples. While chain of thoughts is like a step-of-step way of thinking. Okay, so instead of jumping directly to an answer, the model explains its reasoning, improving the accuracy on complex tasks like math and logic. Do you think that large language models can do math in the prompts? Actually, the answer is no. They don't do math. Large language models are considered as tokens generator, which means that they generate the next token based on the previous tokens they have seen. So the next token will be the token with the highest probability with sampling based on the previous token. Okay, so as usual, you will find the link for this notebook below in the description. Please don't forget to like and subscribe at the end of this video for more lessons and tutorials. First, if you need to download all the requirements and the libraries, you can just run this cell. You can remove the comments. So first of all, I import Torch, LLaMA tokenizer, LLaMA for causal large language model. And this is my model checkpoint. I will start with a small model, which is the 7 billion parameter variant, chat variant from Hugging Face, from NousResearch. And later we will see if we use bigger model, which is the 13 billion chat variant model, and we will see the difference. Then I will import the tokenizer for this model, and later I will get the model for this model checkpoint. Okay, then I will set the model into the inference mode, which means that I'm not going to train model. I will use it to the inference. Okay, after I run this cell, it will download the tokenizer and the model files for us. Okay, and it will take time for the first time you run this cell. After that, it will not take any time. This is a side section where if you want to use the same model, either the 7 billion parameter variant or the 13 billion parameter variant from Meta LLaMA itself, then all you need is to link your notebook with Hugging Face using this cell. And as I showed before in a previous video, you just go to your Hugging Face account, generate an access token, and copy it and paste it in the prompt that will appear after running this cell. Then the only difference is that I'm going to use the Meta LLaMA. Okay, so I'm leaving this to you. You can do it on your own. So this is the end of this side section, and I'm continuing my lesson with the NousResearch model. So first, I'm using a helper function from this GitHub account. You can just click and copy it and paste it and modify it. That is used to build the prompt for us in if we are going to use like a chatbot or something. And it defines a message structure that takes one of three rules: system, user, and assistant. You can refer to the previous video here. I will show it. I will show a previous video that I talk more in details about this function. And to prepare the prompt for us in system message, user message, and assistant message formats. It will wrap the prompt for us inside the instruction and instruction clause in square brackets, and it will put the tags for us, and it will add the end of sequence token and the beginning of sequence tokens into our prompt, as we will see right away. Now let's start with the zero-shot chain of thoughts reasoning. In zero-shot chain of thought reasoning, I'm using the real model power. So the model is giving a new questions without any examples beforehand. And in that way, it must reason through the solution purely from the current prompt based on the parameters or the knowledge it has in his parameters or for the training. And our question here, a factory produces both widgets and gadgets. For every 5 widgets, it uses 3 units of material A. For every 4 gadgets, it uses 6 units of material A. On a particular day, this factory has produced 20 widgets and 16 gadgets. If the factory only had 50 units of material A at the start, how many units of this material will be left over after the production? Okay, and this is like a simple math problem for elementary school, and I want to see how the model would answer that using its token generation motor. Okay, and what do you think we should expect as an answer? Okay, so now I defined the message, and I defined the system message. I didn't specify any rule for now. Okay, you can modify that. It will be like an exercise at the end of this video. Okay, and this is my user message. Okay, so I give it the question and I put them in lists of messages and print them. And now I'm taking the prompt into the tokenizer to print how many tokens in my prompt. And we can see here that it is 132 tokens. And then I defined a pipeline API for text generation with my model, the 7 billion parameter chat variant, and with the same tokenizer, with the same generation configuration that which we used in a previous video, like don't generate more than 2000 new tokens. And I passed the prompt to this pipeline and don't return the full text. And then I digged into the JSON object for the response to get the generated text, and looks what is going on. The model by itself started reasoning this problem, and this is what it generates. To solve this problem, we need to use the information given in the question to find the number of units of material A for each type of product, blah, blah, blah. And then for the widgets, it started to reason how it calculates the answer, and it gets like, it looks like he's calculating a good answer, okay? But at the end, it subtracts everything, and then it tells us that 11 units left over after the production. Now, do you think this is the correct answer? Of course, no. What we should expect that is we only have 14 units of material A after production, and this is the correct calculations. The problem the model generated was because when it tried to calculate the number of units for the widgets, it did not do the math very well. We only require 12 units because we have 4 groups of 5 widgets. Now, this is the result for a zero shot, which means that the model did not have any other examples in the prompt to learn from. Okay, now let's try to add example to the prompt to let the model know how it should answer this problem. So if we look here in one-shot learning, the model is provided with a single example beforehand to solve the problem. And if we can see, if we look at this prompt example, okay, I give an example along with its answer, okay, and then our problem followed by that. I'm running the same helper function. It wraps my prompt and put it into a list of messages. I don't need to import again, and we can see that we have here more number of tokens. Okay, and then I took the prompt and passed it to the pipeline, which again, it does all the steps for us, starting from the tokenizer, passing the output of the tokenizer to the model. The model will generate tokens. I will take the tokens and transfer it back into text. I digged again into the JSON object for the response I received from the pipeline API. And here is the generated text. Great, let's solve the next question. So again, it started by solving the questions directly, not looking at the problem, at the examples, okay? But the answer it gives us is totally wrong again. And this is why I told you that large language models, they don't do math, okay? They just generate tokens, okay? So even if the tokens looks like this is a mathematical operation, okay, it does not really do math. But there are other tools and other frameworks that you can use with the large language models that will help extract the input parameters, pass it to a already predefined function or list of functions, choose the correct function or method, and it does the math for you and returns the results back to the large language model. Okay, now with few shots chain of faults reasoning, I'm not only using one example, I will add more than one example to my prompt. So in few shot learning, the model is giving multiple examples that guide it to follow a specific reasoning process before solving a new problem. And here I give it two examples. A tank fills in 5 hours with two identical pipes working together. How long would it take only one pipe to fill the same? And the answer for this question. Another example, a car travels 300 kilometers using 25 liters of fuel. How much fuel would be needed to travel 480 kilometers at the same rate, along with its answer? Then my question that I want the model to answer it for me. Again, I took this prompt, I wrap it into the prompt structure for LLaMA. Again, I took the prompt. I don't need to import and run all of this again. And now I have more tokens for the model. And again, model started to solve the problem. Okay, it did not get the correct results. So how many examples should we take? Actually, it's best practice to use up to 5 to 6 examples. And then you need to reconsider your options. Either you fine-tune the model or you can use a different model, okay? Now I'm using LLaMA-2-13B chat variant from Hugging Face from NousResearch, which means it's a bigger model and it should get me better reasoning. And I loaded the pre-trained tokenizer for this model along with the pre-trained model for this model as well. That's why I'm using the same model checkpoint. I put the model into inference mode. It loads the model for us. Then I'm trying a new problem. Okay, a bakery sells cupcakes in box of 6. If a customer buys 8 boxes and then eats 6 cupcakes, how many cupcakes does the customer have left? Okay. Now I take the prompt and pass it through the tokenizer for the model to get the tokenized prompts and print how many tokens do I have. And as we can see here, we have 82 tokens. Again, I will choose the number of the maximum new tokens to be 2000 into a generation configuration object and pass it to the pipeline API, defining my task to be text generation using the same model that we choose with the tokenizer and the generation configuration that we have. Using this pipeline, I will pass the prompt and ask it not to return the full text false, which means that don't return my whole prompt, just give me the generated text, which is your answer. Again, as we can see, the model succeeded to answer this question easily, maybe because it's easier than the previous one. It depends. Don't forget that you can use chain of thoughts and examples to boost your model out. Let me tell you that you can also ask the model to think step by step by passing this through the system message and get a clear rule. This will help increasing or boosting the performance of your model. Okay, so now it's your turn. Let me know in the comments, does the bigger model talks more than required? Sometimes it's a little bit chatty. Okay, try other models as well. Do you need to specify the rule in the system messages? Sometimes yes, it helps. It's one of the best practices to specify a rule for the large language model. And let me know, did you need to tune other generation configurations like the sampling, the temperature, the top probability, and the top K? Let me also know, do you think that the complexity of the shots or the examples and the domain relationships would make a difference? So if I'm using different problems from different domains, would that affect the output of the model? I believe it does. Okay, let me know also, do you think that the similarity between the model training data and your tasks plays a role here? Okay, also let me know, does it work with other tasks? Yes. Few Shots Learning works with other tasks like summarization and translation. Don't forget to let me know what do you think in your comments. I will have other 2 videos or lessons talking in depth for the chain of thoughts and the few shot learning. So please do use few shots learning with chain of thoughts to boost your model output. Thank you for your watching. Please don't forget to like and subscribe for more videos and lessons, as you will find a link for this notebook on my GitHub account below in the description. Thank you. See you in the next video.